In this video, we are going to solve a problem on magnetic moment of the transition metal complex. The question is the complex that shows orbital contribution to the magnetic moment is, they are given 4 compounds: copper 2 plus, nickel 2 plus, cobalt 2 plus and chromium 2 plus. Before going to that, let's discuss how do we calculate the magnetic moment for complex. The most common one, spin only formula or spin only magnetic moment. You may be very familiar with this. It is given by the formula 4s s plus 1, root of 4s s plus 1. Or you can give like this also, square root of n into n plus 2, where n is number of unpaired electron. Here s is the spin value, total spin. For each unpaired electron, the spin is half. So how many unpaired electrons are there? Multiply by half. So you will get s. So this is most common. You may be very familiar with this. Suppose if there is orbital contribution, not only spin magnetic moment, to that the orbital angular momentum also contributes some magnetic moment. In such case, we go for another formula. In that we consider the spin only magnetic moment and the orbital contribution also. It is given by this formula 4s s plus 1 square root of 4s into s plus 1, that is here also. In addition to that, L into L plus 1. So this is spin contribution, this is orbital contribution. You can try to calculate the spin only magnetic moment. I try for D1 system. It is given by the formula square root of 4s into s plus 1. S value, it is off since there is only one unpaired electron. 4 into off plus 1. So what we get is 2 into 3 by 2. This will get cancelled. What I get is root 3. So if you find out the square root of 3, you will get the value. So it will be around 1.73. You can try to calculate. I go for the other formula, that is n into n plus 2, where n is number of unpaired electrons. In D1 system we have only one unpaired electron. So what I get is 1 plus 2, 3. So total will be 3. That also will be 1.73. So basically you will get the same answer for both the formula. Now this is a calculated one. Whatever observed by the experiment may be same as the calculated, or it may deviate. If you deviate from the calculated one, that means there is orbital contribution. Now the question is, for which system there will be orbital contribution? We have a very simple rule. If the ground state is A or E, the term for ground state, if it is A or E, then go for spin only formula. There won't be any orbital contribution. If the term is T, then there will be orbital contribution. So this is whatever you have to remember. For A and E grounds term, there won't be orbital contribution. If the ground term is T, then there will be orbital contribution. Let us recall the terms for D1, D2, D3, D4 and D5. When there is only one electron in the d orbital, the L value will be 2, so this will be D term. When there are two electrons, the L value will be 3, it will be F term. When the number of electrons is 3, that also will be F term because the third electron will have 0 L value. When it is 4, once again it will be D term. When it is 5, the L value will be 0, because of that it is S term. I got this L value from this. This is 2, 1, 0, minus 1, minus 2. So when there is one electron, 2 electrons, I have to add this, 3 electrons, I have to add this 3, 4 electrons, I have to add 4, like this. Now this D is getting splitted into T to G and Eg. So when you go for D1 term, the ground state term is T term. There will be orbital contribution. When you go for D2, this F term is split into T1G, T2G, A to G. So in this, the ground term will be T term. So if it is D1 or D2, there will be orbital contribution. What about D3? D3 also it is F, but it is reversed. The terms will be A to G, then T to G, T1G. Whatever was the ground state will have higher energy here. So in D3 system, we have A to G as ground term. Let's go for the next one. In this case, again it is D. It is getting split into EG and T to G. So in D3 and D4, the ground term is A or E. So there won't be any orbital contribution. What about D5? In this case, there won't be splitting at all. We will have A1G. So it is not T. But in D1 and D2, we get T term as the ground term. There will be orbital contribution. I proceed further. D6 and D7. This and this, they are same. So D1 and D6, they are same. D2 and D7, they are same. So in this case also, we will get T to G and AG. Here T1G, T2G and A to G. So in the case of D6 and D7, once again we get this term, and the splitting will be T to G and EG here. In this case, T1G, T2G and A to G. So the ground term is T term. Because of that, in D6 system or D7 system, you can expect orbital contribution. Now we have to find out D6 or D7 system from the given options. When you go for copper 2 plus, it is D9 system. D9 system is equivalent to D4. What we get is EG and T to G. So because of that, there won't be orbital contribution. What about decal 2 plus? This will be D8 system. D8 system is equal to D3 system. The terms will be A to G, T to G and T1G. In that we get A term as the ground state. Because of that there won't be orbital contribution. Let's go for the next one. Cobalt 2 plus. This one will be D7. So in D7 the ground term will be T1G, T term. So because of that orbital contribution will be in this. Next one, chromium 2 plus. This will be D4. D4 and D9, they are identical. The ground term will be EG. So because of that there won't be orbital contribution. So to solve this, you should have some idea about the electronic term as well as the splitting of the term under octahedral field.